Now, whether the movement-resisting force of friction is a bad thing or a good thing really depends on what you're trying to do with friction. For example, friction between your feet and the ground can be a pretty good thing. It keeps your feet from slipping out from under you when you're trying to walk, or run, or jump. Friction keeps your hands from slipping when you're doing things like swinging on a rope, or gripping the monkey bars, or catching a monkey. And it's because of the friction between the strings of a violin and the bow that rubs against them that you get to hear me play. Okay, so maybe that's not such a good thing. The point is, friction really is everywhere and anywhere something is sliding or wants to slide on something else. But what, you might ask, causes this movement-resisting, sometimes helpful, sometimes not so helpful force between surfaces? To see that, we'll need to use Super Micro Shrinker Vision. Okay, it's really just a special effect, but try to play along anyway. Here, you gotta put these on. Cool, huh? But we're not quite small enough yet. Let's keep going. Check it out. You're seeing a microscopic representation of where the surface of the glass actually meets the surface of the bar. These mountain-like peaks are called asperities. See, whenever two surfaces are in contact with each other, there are actually tiny individual points of contact on each surface where the asperities touch. And as two surfaces rub or slide against each other, it's at these points of contact that friction is happening. And when we take an even closer look, excuse me, Yeti, those aren't mountains. What are you doing here? Well, as long as you're here, I could use some help with the animation. Sound cool? Let's take an even closer look at the cause of friction. Atoms. Let's say we've got two surfaces, one red, one blue, that are sliding against each other, and that each of these little yetis represents the many, many tiny atoms at each contact point. Whenever and wherever contact points touch, the atoms start touching too. It's the touching of atoms at these contact points that actually causes the movement-resisting force of friction. Now, as you might imagine, the more the surfaces press on each other, the more contact points you get, which means more atoms start touching each other, and that means more friction, more resistance to movement. In fact, it's proportional. Twice the force, you get twice the friction. 3 times the force, 3 times the friction, and so on. And get this, in some cases, depending on the surface material, the atoms actually stick to each other momentarily. This is called adhesion, which is an electric attraction, and it too contributes to friction. No, guys, you're supposed to be sticking, not dancing. Guys, we're talking about friction. Guys?